See that cliff? There's treasure up there. There's fossils in them there hills. Let's go!
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Old Stuff Incorporated. You'll dig it.
Did you know that almost all the things that have ever lived on Earth are gone? And it's not just that the living things are gone. The kinds of living things, the species are gone. And we figured this out when we found their fossils. Fossils from an old Latin word that means to dig. Dig, so fossil this. Have you ever seen a three-toed horse?
Well.
Or a camel in the middle of North America? Or a rhinoceros in Nebraska?
Can't say I have.
Take a look at this. That's a three-toed horse, and this is a rhino. And we're in Nebraska. Now, these are actually fossils of rhinos. And fossils are evidence of living things that have turned to stone. Fossils usually tell a story. The story here is 10 million years old. These animals all were breathing bad air, probably from a volcanic eruption, hundreds of kilometers from here. They came here to get a drink, and they died. And then volcanic ash was blown in by the wind, and they were buried. And about 10 million years later, they're still here. This is something we don't get to see very often. The fossil skeleton bones are all held in their original position. So here we have a snapshot, a three-dimensional picture of the past. Now here's the thing. There's no rhinoceros quite like this one anywhere in the world today. And there are no rhinoceroses at all anywhere around here. Things on the Earth have changed. Different kinds of living things have come and gone. Some of them are extinct. In fact, 90% of all the living things that have ever been on Earth are gone. They're extinct. And we figured it out from fossils.
I gotta go. Yeah, my trilobite's here. Later. Okay, buddy. Cut. You are dead. Don't mean that as a criticism. The fact is you died millions of years ago. But how many prehistoric living creatures just happened to get covered over with mud and then turned to rock that left an impression? How many? Not many. You are special.
A shell pressed into soft clay forms a mold that preserves the contours of the shell surface. When plaster of Paris is poured into a mold and allowed to harden, a cast is formed. This trilobite has been beautifully preserved as both a cast and a mold.
Not all fossils are bones that have hardened into rock. Sometimes when a plant or animal dies, it leaves an outline behind, like this.
Here's an easy experiment to see how some plants and animals leave a mark when they die. Just take some paint and brush it onto one side of an object, like a fish.
Or a fern.
Okay, now knock it off. You're gonna spill that all over the place.
Then carefully pick up your wet painted object of science and lay it on a piece of paper.
Or a tile.
Just like a plant or an animal that has died
Excuse
and left a
me,
mark.
no. The paint leaves a trace behind, so it's just like a plant or animal that's died and left a mark behind.
Anyways, it's just like a plant or an animal that has died and left a mark.
I didn't say what I was supposed to say.
Well, sorry, you said it.
Yeah, you messed up.
I'm sorry.
Wait. The paint leaves a trace behind.
It's just like a plant or an animal that has died and left a mark.
Kind of like this leaves a mark?
You know, you made a good point. But I think it was, it leaves more of a mark like this.
Those are bubbles of natural gas, what we call methane gas. Now, methane and gasoline and oil and tar, well, they're all kind of the same stuff. See, we're at the La Brea Tar Pits.
At the La Brea Tar Pits.
In Los Angeles.
In Los Angeles.
California.
California.
In the United States.
A display has been built depicting this prehistoric pool of tar.
And the tar has been here for a long time.
25,000 years ago.
Animals,
giant mastodons,
came down here to get a drink of water, and they got
trapped in sticky tar.
And their bones, their fossils, are still in there. Okay, the animals have gotten in the tar, they're buried, they've sunk. Then 15,000 years later, a scientist like you comes along.
Uncovering the bones of many different kinds of extinct animals.
And digs up an oily fossil like this one.
Preserved in their original condition by the asphalt-like material.
Now this is a saber-toothed cat. You ever seen a cat like this? No, you're not gonna see one either because they're extinct, they're gone. But their descendants are still around, although probably don't have teeth quite like this anymore, do they?
From fossils, we have assembled a nearly continuous record of millions of years of life on Earth.
Isn't that wild? It's fossils, it's evolution.
Check it out. What does it look like to you? What do you guys think this is?
Fang.
Exactly.
This is a stick, and it's all fossilized. It's rock hard.
I think this is a pretty neat one. We're almost sure that it's a tooth from a saber-toothed tiger.
So what we want to do is locate which layer your fossil was at and where in relationship to the other landmarks your fossil is.
Millions of years ago, this place was tropical, and these sycamore leaves fell off trees, and then there was a big mudslide, and it covered the leaves, and then they fossilized. I think I have a tooth. It's either that or a rock.
We use markers, like little tacks, to mark places where the fossils are so that the scientists know where to look for some others of that kind.
It's hard to imagine how much time has passed since even the youngest fossils were formed. Please consider the following. Now, if each popcorn kernel represents 1 year, well then, this many kernels would be the number of years that you'd need to get a PhD in, say, computational fluid dynamics. Now, dinosaur fossils are hundreds of millions of years old. I mean, it's hundreds of millions of years. That's way more jolly kernels than this. In each of these bags, there's about 5,000 jolly kernels in it. That would be 5,000 years. That would be as old as the pyramids. But that's not that much. Like, I could eat this at a double feature.
I'll bet you could.
To get back to some of the oldest dinosaurs, we need tens of thousands of these bags. 150 million years, 150 million kernels of popcorn. It's enough to fill a whole boxcar. It's more than you can eat in your whole lifetime. Some of the oldest fossils are 3 billion years old. We need all the kernels in 2 of these silos. Billions of kernels. 2 of these silos. Billions of years to equal the age of the oldest fossils. Billions of years. Billions of kernels of popcorn. Fossils are very old. Thank you for joining me on Consider the Following.
Stressed out, run down, Dead tired? Maybe it's time to try a La Brea hot tub. Slip into a pool of luxurious hot tar and let it cradle your bones for thousands of years to come. So sit back, unwind, relax in a La Brea hot tub. You're not getting any older, you're getting better preserved.
This is a tree, or it used to be a tree. It used to be made of wood, and now it's a rock. It's petrified wood.
All of the original wood is gone and has been replaced by minerals.
It was living in a swamp around here about 10 million years ago. Here's what happened. A volcano erupted, and the water in the swamp turned to steam. All the trees got washed downstream into a big lake. And the lake filled with volcanic ash. Ash has a mineral in it called silica. It's just like glass. The silica soaked into the wood, and when the lake drained away, the wood had turned to stone.
This process is called petrifaction. Petrifaction can be simulated in the laboratory. A sponge is saturated with liquid paraffin. After the paraffin hardens, the sponge is cut open. The pores in this sponge have been filled, just as the pores in the wood were filled with minerals.
Look at it. You can count the rings and the layers. This tree was hundreds of years old, and it lived several million years ago. It's a fossil. Some fossils were made like this.
Yeah, they're traces of things that used to be alive.
That's right. There wasn't a lot of wet cement around in ancient times, but there was wet soil and soft tree sap. So if a living thing made an impression in it and it dried out and hardened, you might get a fossil. But most impressions get smoothed away or filled in over time. Hey, Suzanne.
Yeah?
Does that look like a Tyrannosaurus Rex footprint?
Fossil evidence of this kind may reveal important information about the size, weight, diet, behavior, and even the environment of the animals that have lived in the past.
Now, Grace, what's going on right here?
Well, those look like dinosaur tracks. And it looks like we have enough of them here so that we can measure the stride and figure out whether this dinosaur was walking or trotting or running. Let's take it from the first print to the third one.
So here's the first one.
Yeah.
So I'll put it right here, right on the toenail, huh?
Toenail, the third toe, the middle toe. And I'll go over to the top of the third toe of this print. That would be like from one right foot to the other right foot print. And
yeah, that's the
here's
left there.
The top of it there. This is the middle toe, so we'll put the tape right here. So that measures about 220 centimeters.
Doesn't look like he or she was running.
I think they're just a gentle walk. We study animals today, and we can relate them back to the fossils, and it works in reverse. From the fossils, we can relate to the animals that are living today. By measuring the footprints that are embedded in the rock, we get an idea of how big the foot itself was that made the print. From the foot itself, we can build the rest of the bones up and figure out how big the whole animal was. Dilophosaurus was about 18 feet long, and we think that he's the dinosaur that made the footprints that we've been studying out here.
Probably a Dilophosaurus. Went hopping through here, probably looking for food or water. 200 million years ago. Jurassic period. Hopping through. Dilophosaurusizing.
Nothing says loving like a fossil from an extinct fossil bake oven.
Now you can make your own fossils right at home. Just get a dead organism, add soil, mud, ash, or amber. Then compress it, perhaps even freeze it or dry it out. And then wait thousands, even millions of years, and voila! Just like that, you've made a fossil.
Nothing says loving like a fossil from an extinct fossil bake oven.
From Extincto.
How do scientists know how old fossils are? Well, we usually start by figuring out how old the rocks are around the fossils. See, fossils are usually found in sedimentary rock, which is laid down in layers, kind of like the layers of a cake. Yum. This cake has different layers. They're different colors and they're different thicknesses. In the same way, fossils are found in rocks of different kinds, and the layers of rock are different thicknesses. Now here's the thing. If scientists find a fossil in one layer of rock in one part of the world, we might find that same layer of rock in another part of the world. So if we know how old the fossils are here, then we can figure out how old they are in another place. Now in this cake, between the chocolate and green layers are where we find the fossils of rubber dinosaurs.
Hello, Clark Kite, Daily Fossil Record. Lady, take a breath. Let me get this straight. Millions of years ago, dinosaurs roamed the earth? This could be the biggest story of my life. You got any proof? You've got actual traces of dinosaurs?
Extra, fossils tell sordid tale.
If fossils could talk, they could tell us a lot. Like if we found these seashell fossils or this fish fossil in the middle of the desert, we'd realize that they lived in a place that was probably once underwater.
Will you get on with this, please?
And then if we found this fossil, well, it turns out to be a tooth with these small grooves, and it's flat. This is the kind of tooth of an animal that eats plants, grinds them up. So this would be a tooth from a very large vegetarian. And then this was the tooth that's used for piercing, tearing, and ripping flesh. This was a tooth from a very large meat eater. Meat eater. Of course, the fossils don't actually talk. They don't really tell stories. You just, being in the lab a lot, you know, with the fossilized specimens, you get a little loopy is all.
I'm really lucky to have one of the best jobs you could possibly have. I get to look in rocks like this, in beautiful places like this, and find fossils of mammals that lived here 30 million years ago. Fossils are the traces or remains of any ancient life. Most of the time, the tools of our trade are little tools like these. We're not out here with big, heavy hammers smashing these things at all. For the most part, we're using extremely delicate, careful tools when we're near the bone. These are 30 million years old. It's the only one of its kind sometimes ever found. One slip and we've ruined it.
Yeah, tell me about it. It can take anywhere from 10 minutes to 200 hours, depending on the size and the rock. With this one, we'd like to leave it in a lot of the rock to show how it was ripped apart by some meat eater. And it isn't a nice backbone with a skull and a tail and the legs. It's the backbone, a leg, a skull, another leg. So they're extinct now, but they lived very, very well for millions of years with other animals that they're also extinct.
Fossils are used as guides to build replicas of ancient animals, showing how they might have looked when they were alive.
This is a famous and important fossil, Archaeopteryx.
The Archaeopteryx, meaning ancient winged one.
Archaeopteryx means ancient flyer. See, it's a dinosaur with feathers.
The light, fluffy feather of a bird is closely related to the scale of a reptile.
It was this fossil that made scientists realize that dinosaurs and birds must be related. The hard parts are preserved, the bones, but so are the soft parts, the feathers.
Archaeopteryx.
In fact, feathers have the same chemical composition as scales.
So studying this fossil, scientists created this model. It's patterned after tropical birds. Scientists just made the colors up.
Bill, Are you going loony again?
I made that up too.
Mm-hmm.
Take a look at this. Here are a couple of flies that are stuck in the tar. They're going to be fossils someday, just like those other animals. It's still going on. Don't kid yourself.
Last night I dug myself a trilobite bite. Now a rock, once alive. But it came out alright, 'cause it's fossilized. Oh, it's such a long time. And I know that fossils take a long, long time to form before humans like me can find and learn about the past of life on Earth. Oh yeah, yeah, yeah. I'm a fossil man. Fossil man, digging fossils up out here all night. And I know that fossils take a long, long time. And I know that fossils take a long, long time. And I know that fossils take a long, long time.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some Miocene sedimentary deposition angles to verify. See ya!
Produced in association with the National Science Foundation.
Welcome back to the Fossil Gourmet. I'm Bill. We're just going to go over again how to make a fossil. First of all, you want a living thing. It doesn't have to be alive. Something that was once alive will work fine. And for your first fossil, I recommend using something with a nice hard body part, a skeleton, some bones, or a shell. Put that in the dish. Now we want to bury it. Use sand, or I like the flamboyant presentation of a volcanic eruption. It works very quickly, and it's loaded with minerals. Now you want water. You've got to have water that's soaked with minerals. That's the key. And you can get the minerals right out of the volcanic ash that's buried, and you can get the water from a flash flood, a river, or just a simple torrential rainstorm. And then lastly, the most important thing, time. That's what you've got to have is time. Well, thanks for joining us on the Fossil Gourmet. I'll see you next time.